How does the world communicate? It sounds simple now, but to understand the future of connectivity, we have to look back to its fragile start. It all begins in the 1960s, not as a public utility, but as a top-secret military project in the US. The Cold War was on, and the Department of Defense needed a communication system that could survive a nuclear strike. The result was ARPANET, the world's first packet switching network. The idea was brilliant. Instead of one central switch, data would be broken into small packets, sent through a decentralized web of nodes. If one node went down, the data would simply reroute. The very first message, sent in 1969 from a computer at UCLA to one at the Stanford Research Institute, was an attempt to type login. The system crashed after the L and the O. A tiny moment, but a monumental shift. That military network, built on an ethos of resilience, was quickly adopted by universities and researchers. They wanted to share information freely and globally. But a decentralized system of just 4 nodes isn't a global network. The true breakthrough came in 1983 with the adoption of TCP/IP, the common language that allowed different networks to finally talk to one another. Suddenly, ARPANET evolved into the Internet, a true network of networks. When the World Wide Web arrived in the early 90s, with its simple web pages and browsers, the public desire for connectivity exploded. Everyone wanted in. The desire wasn't just for a secure network, it was for a universal one. But as the Internet went from a government project to a global phenomenon, the infrastructure to support it became massive and expensive. Building and maintaining cell towers, fiber optic cables, and core routing centers requires trillions of dollars and massive corporations. This centralization created a new conflict. The Internet became a bottleneck, dominated by a few major telecommunication companies who control the physical access, setting the price, and deciding where coverage exists. The original decentralized spirit was lost. And the result? Coverage gaps in rural and developing areas, high monthly costs, and a reliance on singular points of failure that can be compromised or censored. The universal network is still out of reach for billions. The digital world realized that to fix the centralized Internet, it had to return to its decentralized roots. But this time with a modern twist, the Decentralized Physical Infrastructure Network, or DePIN. Enter. Decentralized Wireless. This movement changed the industry entirely. Instead of one massive company building giant towers, DeWi uses blockchain incentives to encourage thousands of individuals to buy and deploy small, low-power radios in their homes and businesses. Projects like Helium pioneered this by having individuals run hotspots for massive community-driven IoT and 5G networks. Other innovators like World Mobile are tackling connectivity in underserved regions like Africa, while emerging projects such as XNET, Dawn, and Dabba are all working to put network ownership and control directly into the hands of the users. These ordinary people become the new telecom providers, building a community-owned wireless network from the bottom up. They earn cryptocurrency rewards for providing coverage and transferring data, shifting ownership from the corporation back to the crowd. The result is a return to resilience. A DeWi network, owned by the community, is more robust against single points of failure, more affordable, and can organically expand into remote areas that centralized telecoms ignored. It's the Internet's journey coming full circle, from a decentralized network for the government to a centralized network for corporations, and now to a decentralized network for the people. The real question isn't whether this new infrastructure will work, but how much faster it will connect the next billion people. Because when the world moves the network, everyone gets to talk.